In this video, we want to show that this function u equals f of c times x plus at is a solution of the wave equation, which wave equation is this. Second partial derivative of u with respect to t is equal to a to the 2, which is a constant, times by the second order partial derivative of u with respect to x. So this is an application of partial derivatives. First, we start with finding partial derivative of u with respect to t. But before that, let's rewrite the given function u in the form of f of cx plus cat or act. The order doesn't matter. So we multiply the constant c in the bracket and we rewrite the function u in the form of f of cx plus act. It's not really necessary to multiply c in the bracket, but for u, maybe finding the derivative of u is easier if you rewrite the function in this form. Let's start. What is the partial derivative of u with respect to t? Here the function f is unknown. It can be sine, it can be cosine, it can be a square root. So we have f of an expression. And for finding this derivative, we have to use the chain rule. So let's start. Derivative of f would be f prime. So f prime of cx plus act. Attention, derivative of f is f prime. F is a function, a general function. Then multiply by derivative of the inside. But derivative of inside with respect to t. So derivative of cx with respect to t is 0. Derivative of act with respect to t is ac. Because a and c are constants, so derivative would be ac. Derivative of act with respect to t is ac. This is the first partial derivative of u with respect to t. Now from this we have to take derivative again with respect to t to find the second order partial derivative of u with respect to t. For finding derivative of this, ac is a coefficient, so we keep the coefficient here. Then we have to find derivative of f prime. Derivative of f prime is f double prime. So f double prime of cx plus act. But again, we have to multiply by derivative of the inside. Derivative of cx is 0. Derivative of act would be ac. And ac multiplies by this ac. So at the end, we have a to the 2, c to the 2. So we have to put a2, c2 here. And this is the second order partial derivative of u with respect to t. Now, let's start with the other part. We want to find the partial derivative of u with respect to x. Derivative of f again is f prime cx plus act, and derivative of inside with respect to x is only c. From this we have to take derivative with respect to x. Derivative of f prime, c is a coefficient, we keep the coefficient here. Derivative of f prime is f double prime of cx plus act, multiplied by derivative of the inside based on the chain rule. Derivative of the inside, derivative of cx is c, and derivative of act is 0. So derivative of inside is c, and if we multiply that c with the c that already we have here, it would be c to the 2. Let me name this equation 1. For uxx, we have to multiply by a to the 2. A to the 2 times uxx would be, uxx is this expression. If we multiply both sides of this relation by a to the 2, then a to the 2 uxx would be a to the 2 c to the 2 f double prime cx plus act. And let me name this equation number 2. By comparing equation 1 and 2, we can see that utt is this expression is equal to a squared uxx. So we prove that the given function is a solution for this equation, which is famous to wave equation.